Okay, in this video we're going to be exploring mirror lines. So mirror lines in your high school geometry class were probably called reflection lines, but as Conway often does, he tried to make it more tangible by actually thinking about physical mirrors, and we actually are even going to look at some physical mirrors and look at what happens when we lay them on our mirror lines. But the idea is that any place where there's a line of reflection in our pattern, there's going to be the same thing on both sides, and so that means that there's multiple copies of the same thing, and we're trying to get, in all cases, we're trying to get the entire pattern down to just one copy. So anywhere we have mirror lines, we know that we can eliminate copies of the design. So what we have here is some kind of straight edge for making straight lines. We're going to use red colored pencil because Conway likes to color code the types of features into red and blue. We've got some tape to help us hold the mirrors together when we actually get to that. And then we've got a copy of the first page of handout number 3, which is a pattern that only has mirror symmetry. It doesn't have other types of symmetry in it. And what we're going to do is start by trying to find some mirror lines in this shape. And that's what we're going to do right now. Okay, so we're looking for a place where the pattern is the same on both sides here. And there's one here. One thing you can do is sort of look for centers of rotation, because those a lot of times are going to fall on mirror lines. But we have one that we found here. And once we find one, we're just going to mark it with a straight line. There's other ones that are parallel to this first one. There's one I see right here, and we can mark that one. And there are other ones that are facing in different directions here. What we're trying to do is trying to find a region surrounded by mirror lines that doesn't itself contain any mirror lines, because we know that that's going to be a region that's repeated over and over again. So there's one. And then there's one more direction here that the mirror lines face along this dimension. And here's one. And you can see now that we have a triangular region here. And inside it, I don't see any more mirror lines. So this should be a region that contains all the information I need to generate the entire repeating pattern. So what we're going to look at next is what happens if we actually put mirrors along these mirror lines, and we can see whether we can see the whole pattern by doing that. So I'm going to start by taking a few pieces of tape and setting them aside. These are just to help me hold the mirrors when I have them where I think I want them. If you have a partner, you could have your partner hold the mirrors while you look. And we're going to start by just laying a mirror right along one of those mirror lines. And if you look, you can sort of see the pattern continue. So whether I have the mirror there or not, it kind of looks the same. So I'm going to lay another mirror right here. And then I want to kind of tape those two mirrors together so they don't go anywhere. Okay. And then I'm going to take a third mirror and lay it along the mirror line that's going in the third direction. So now all that you're seeing in those 3 mirrors is the region that's enclosed by those 3 mirror lines, but the region is repeating over and over again. And if you look from side to side, you can actually see the pattern continuing. You may have noticed that this region that we found here appears to be an equilateral triangle, and that's not an accident. It is, in fact, an equilateral triangle. Conway calls symmetries created by mirror lines kaleidoscopic symmetry, referring to kaleidoscopes, and that's actually what we just made, was an actual kaleidoscope, like the toy that you play with when you're a kid. And there are only certain kaleidoscopes that are possible, just like there are only certain symmetries that are possible. And one of those geometries is the equilateral triangle. You can also have a rectangle is another geometry that's possible for a physical kaleidoscope, if you want the kaleidoscope image to extend infinitely in every direction. The only other possibilities are a 45-45-90 triangle and a 30-60-90 triangle.
So this kind of wraps up what we want to say about mirror lines, but that's not the only way that patterns can repeat. And so our next video is going to talk about some things, some other things, such as rotations that don't have mirror lines.